Okay, 4.2. The last bit of 4.2. These are some pretty important problems because a lot of times they put real life problems on the state test. Life problems that have to deal with trusses, plywood boards, remodeling houses, making all sorts of things, zip lines and stuff like that. So here's a real life problem where they make trusses, and these trusses are made out of what's called isosceles triangles. We talked those yesterday, okay? So isosceles triangles, what's the deal with isosceles? Do they have one side that's right? Do they have two sides that are congruent? Or do they have all three sides that are congruent? Two sides, good. Two sides are congruent, right? So therefore I know right away when it says PQ, PR, that PQ and PR are congruent, okay? So just know that that's the way we got to go with it. Now the other thing that we need to make sure is they tell us that it's 4/3. Okay, the side that's longest is 4/3 the side that is congruent. Okay, so what's that telling us? It's telling us that this side right here, okay, is 4/3 this other side. So if we allow those to be x's, okay, if I allow this side to be an x, oops, well, come on now, oh, someday, not today. If we allow this side to be x and this side to be x, right, then we have this side will become 4/3 x. Okay? Does that make sense? Does that make sense, everyone? Okay? Alright, so they tell us that the perimeter is 60 feet. The perimeter is all the sides added up, right? So all we really need to do is add these sides up. So x plus 4/3 x should equal 60. Is that right? Yeah? Yeah? Good? Okay? Alright. So, what do I do? What do I do with this? Why do I know that that's true? Why is that true? Why can't I add up all the sides and say that they're 60? Well, lets me say that. Because
equal angular?
Not equal angular.
Lateral?
No. What's it? What is this?
Perimeter?
Perimeter. Right? So what's this? The perimeter, right? It's just saying, hey, all the sides added up is the perimeter, right? So if we say because it's the perimeter, what are we really going to say? Instead of because, we use what word? Come on, people. Wake up. I know it's first period. What word instead of perimeter? What word instead of because? Definition. Right? Definition of a perimeter. That's it. Definition of P. Okay? Definition of being a perimeter tells me that I can add up the sides, right? And make it equal to the perimeter. That's it. That's all we're saying. Now what do? We just add the x's. So what's x plus 4/3 x? Right? So what's 1 plus 1 plus 1 1/3? Come on, guys. What's 1 plus 1? Come on. Okay? 2. Yes. What's 2 plus 1/3? People, you're killing me. What's 2 plus 1?
3.
Okay. And 3 plus a third? 3 and a third. That's it. Come on. I'm not tricking you. This is 2nd grade. Okay? We can do this. Just wake up. It's okay. Alright? It's not a trick question. I'm just asking you to add 1 plus 1 plus 1/3. That's it. 3 and 1/3. That's all. 3 and 1/3. Now, we could think of this in a different way. Okay? We could think of this as 3/3 plus 3/3 plus 4/3, right? So then that would be 3 plus 3 is how much? 6. And 6 plus 4? 10. So that would be 10 thirds. Does that make sense? Now 3/3 is 1, right? And 3/3 is 1, right? And 4/3 is 1 and a third, right? But the way we're writing this is so that we can add all of them, because we can't add fractions if the bottom is not the same, right? Okay, so that's the hard part. But think about this. What's 3 times 3? 9. And what's 9 plus 1?
10.
Boom, that would be 10 thirds also. So 2 different ways of doing this problem. Does that make sense? Okay? And the reason we want to do this, okay, so what did we do here? What's that called when we just add it up? You remember? It's really simple. Simplify. Good. All right, you get what I'm throwing down. Okay. Simplify. Thank you. All right, so now what do we do? How do we solve? Come on. We can solve it. How do we solve? What do we do to solve this? Multiply by?
3.
Good. I can do a little better than that. So the 3 is going to get rid of the 3. And the 10, we'll get rid of the 10, right? So what do we call that? The reciprocal, right? So multiply by the reciprocal. And what that allows us to do is what you do to one side, you do to the other, right? Okay? What rule is that? When we multiply on both sides. What do we call that?
Multiplication property of equality.
Yes. Multiplication property of equality. Okay?
What does it say under fine length?
On the what?
Under fine length, what does that say?
Oh, that's just 1/3, 1 and 1/3 x. I showed this yesterday. So what I was saying is basically 4/3 x is really 1 and 1/3 x. Sorry about that. I didn't erase all my work that I did 7th period. It wasn't able to get the video ran out, so I have to redo it today. Is that going? Okay. All right. So now we can cancel, and we get x. And then how many times does 10 go into 60? 6. And then 6 times 3? 18. So that tells me that this side is 18. And that tells me that this side is 18. Right? And that's pretty easy. But what about this side? That would be 18 times 4/3, right? So what is, we're running out of space here, but what is 18 times 4/3? And then that would be called substitution, right? Okay? Alright, so substitution. And then this is really 18 over 1. So what are we going to do? 3. Right? And 6 times 4 is? 24. Okay? So another way you could think about that is if you think, what's 1/3 of 18? What's 1/3 of 18? 6. Good. So we could think of 18 plus 6, right? Plus 1/3 would be also 24, right? So it's another way to kind of think about that. Does that make sense? A little bit? know it's early? Right, Sandra? I know it's early. You're looking at me like, I don't understand what you're doing. Okay? But we're just doing our basic algebra. The hardest part was setting up this. Okay? Now, on the state test, I would not be surprised if they ask you something like this, and then they ask you something like this, which is misleading. Okay? Think about this. How many trusses can be made from 150 feet? Well, that, I don't need to know 18 at all. Do I? Because they're asking me how many trusses can be made. So how many of these? Well, what's the perimeter? The perimeter, you told me, was 60, right? So I don't need to know any of this to answer this. And that might happen on the state test. You might be able to answer another problem without answering the problem before it. So be sure you read it, okay? Because they do this a lot. They use really confusing questions, okay? So how many times does 60 go into 150? So how many times does 6 go into 15? Twice, right? So I can make 2 trusses. Now, in actuality, it goes in 2.5 times, right? So technically, I could make 2.5 trusses, right? But you can't really make a half of a truss. So the best you could do is either make one of these sides or one of these sides. And if I were building the trusses and I only had 150 yards of, 150 feet of material at the moment, then I would build a truss and then I'd build the longest side. So then when I get my next lumber shipment, I can start building more. Does that make sense? And then I can just build these 2 pieces, right, and move on. So then you might want to order different size pieces, right? If you know these are 18 and these are 24, you could start ordering 18-foot pieces and 24-foot pieces. Okay? Does that make sense? All right. Next, 29. You have an equilateral triangle. What does that mean, equilateral?
All sides are the same.
All sides are the same. Good. So I have all sides are the same. Okay? So then I have the perimeter is 150. So if all sides are the same, could I just say that this is x and this is x and this is x? Because they're all the same. Right? Okay. So wouldn't the perimeter be x plus x plus x? Does that make sense? So then it would be x plus x plus x. How much would that equal then? How much would that equal? What's the perimeter? It says the perimeter is how much?
105.
105. So wouldn't x plus x equal 105?
Yeah.
Right? And then what lets me say that? What allows me to say that?
Given.
Not given. Definition of perimeter.
Perimeter.
Right? Definition of a perimeter. Okay? Does that make sense? Right? Okay? Then what are we going to do? Add them. Right? 1 plus 1 plus 1 is 3. So 3x equals 105. What did we do there? What step was that?
Addition, property of equality.
No. Right? What? Help me. Simplify, right? Remember, addition property of equality goes to both sides, but simplifying is just PEMDAS, right? So anytime we're using PEMDAS, we're simplifying, or distribution, right? But when we use SADMEP, right, that's when we're solving, that's when we use the property of equality, okay? So this is simplify, okay? And then what do? We solve, right? And how do we solve? Division. Always the opposite. OPP. I'm going to explain it. Okay? So, what? 35? Yes. So that means each side is 35 feet, right? And then what property is that?
Division property of equality.
Division property of equality. See how easy these proofs are becoming? Okay? They're no different than what we did first chapter, right? The only difference is new rules have started off. Okay? So if you remember that, things will go really good on this test. Alright, next. We're giving this triangle. Now remember, with this triangle, we know that this is a right angle, correct? So that's 90 degrees. We know that this side is congruent to this side, which is also congruent to that side, because they all have the one slash. If one of them had a two slash, that would be different. Does that make sense? Okay? So, what do we know about this triangle, ABC? So let's take a look at A, B, C. So that would be this triangle. What do we know about that triangle? Does it have all three sides the same? Does it have two sides the same, or are all three sides different? What do we know? Two sides are the same. So what do we call that kind of triangle? Isosceles. Okay? So we know it's isosceles. Oops. Wrong one. We know it's isosceles. What else do we know about it? If this side is 24 and this side is 24, how big is this side? 100. Well, 180 for all of it, right? For all three sides, for all three angles. So then it would be 180 minus 24 plus 24, which is 48, right? Is that bigger than 90? Is 180 minus 48 bigger than 90?
Yeah.
Yeah. So what do we know about a triangle that has a side or an angle bigger than 90? What's it called? Is it acute? Is it right? Is it obtuse? A triangle that has an angle bigger than 90.
Obtuse.
Obtuse. Good. I was letting everyone catch up. Good. Obtuse. So it's an isosceles obtuse triangle. Or an obtuse isosceles triangle would probably be more better said, but it doesn't matter. Okay? Alright, next one. ACD. Okay? So we're talking about A, C, and D. Okay? We're talking about this guy right here. What do we know about that guy? What do we know about this blue one? Does it have two sides that are the same? One side, all the sides are different? Or three sides that are the same? What do we know? It's isosceles, okay? We know it's isosceles. What else do we know? That it's a right angle. So it's a isosceles right triangle. And this is huge. Because later on in chapter 7, or actually chapter 8, we're going to learn about 30, 60, 90 triangles and what this is. This is called a 45, 45, 90. Okay? Whenever you have an isosceles right triangle, you're going to have what's called a 45, 45, 90 triangle. Okay? We'll put that in your brain for later. That's it. Not bad? Okay? Alright.